Alright, so final unit, and this one I'm hoping is going to be a bit more interesting for you and a bit fun. So we'll start off by how to represent data by bar graphs, scatter plots, and line graphs. Now I'm sure in several other classes you've had to represent data, science, history, you've done these. So this is going to be short, sweet, to the point, and it's just a quick review. So, start off with bar graphs. You're going to use bar graphs to compare facts of data. So here, in some made-up survey that I did, asked students what they do after school. 40 said sports, 35 said hang with their friends, 20 said earn money, 42 said they participate in school clubs, and 38 said that they play video games. So, what we're going to do is, here we have our bar graph, and all of our graphs are going to have an X and Y axis, and those axes are going to be labeled something. You see here I've labeled the X axis with activities, so that's where all the activities are, and the Y axis is the number of students. And I've just started at 0 and go up by 5s here. So, first, sports. So 40 students said they did sports, so I'm going to go up here, draw a line. There's 40. 35 said friends, so indicate there 35, there's friends. Earn money was 20. Clubs was 42, so 42, that's going to be a little bit above that. Finally, video games is 38, so it's going to be lower, about right there. Actually, let's make it a little lower. So here we go. Here's our bar graph. So the reason that we're representing this data is because there's questions that we can ask, and there's things that we can look at here. Like the questions ask, what is the thing that students appear to least want to do after school? Well, it's quite evident that it's earn money. So a job or something like that. If you were to say, well, what's their favorite thing to do? Well, it looks like sports, school clubs, and video games are all pretty similar. So it looks like students like to do those a lot more, with school clubs being the winner. And we can answer things about this, like if we were going, okay, well, if I want to find something that can get appeal to all these students, it looks like something that has to do with sports, school club, and something with video games would be something that would compare to the most students. So scatter plots. We use scatter plots to compare two types of related data. So here we have an example where we're looking at heights and weights. So height and weight, they're tied together. We're going to use scatter plots when we're doing things like that. Things that are, okay, someone's so tall, they weigh this much. So we're looking at one point, and then we're going to look at another data point that's related to it. So, someone who's 70 inches tall is 180 pounds, 52, 102. You can read the graph. So scatter plots are basically, we're just putting dots on the graph and looking at the dots. Bar graph obviously was bars. Scatter plot, it's just a bunch of different points on our graph. So we have another XY axis. Our X axis is the height of the student. Our Y axis is the weight of the student. And you'll see here that I broke this little squiggle here. That means that I'm breaking the number. It says, okay, I'm going to skip some numbers to go where I want. That way I don't have to start at 0 and try to go up. It says, hey, I'm skipping some numbers because we don't need them. So first we had a height of 70 and a weight of 180. So 70, 180, okay. Get rid of all those dots. It's about right here. 52 inches tall and 102 pounds, so that's right here. 61 inches, so in between 60 and 62. 130, so about right here. 63, 185, and 57 and 120. So you can see why it's called a scatter plot, because these are scattered all over the place. And what we can do here is we can look and say, okay, well, if I were to say just a random height, you should be able to guess roughly what their weight would be of the student. If I were to say they were 66 inches tall, you'd probably not say they were around the same weight as the person who's 52 inches. You'd probably say something that's a little bit more than 130. Whereas if I said 50 inches, you're not going to guess that they're going to weigh 190. You'd think that it'd be roughly in this range. And that's what we use these scatter plots for. We look to see if there's a trend in the data to where we can guess and predict certain points. Finally, we're going to talk about line graphs. Line graphs, what we're going to do is we're going to use data that's going to be compared over time. So here we're looking at temperatures over a week in 3 random cities. And we'd like to see, okay, how does the temperature fluctuate throughout these cities? So here is my graph. On my y-axis I have temperature, and I'm going by 2s after I broke it up, and on my x-axis I have the days, and I forgot to label that, so I should probably do that. So this is days, and because I'm looking at 3 different cities, what I'm going to do is actually use 3 different colors. So the white is going to be city 1, see, red will be city 2, and blue will be city 3. So we don't get confused what's what. So city 1, on Monday it was 70 degrees. So Monday it was 70 degrees. Tuesday it was 72. And what we're going to do is we're going to plot these as points, and then we're going to connect them with lines after we've plotted all our points. Wednesday is 68. Thursday is 71. Friday 72. Saturday 67. And Sunday it was 72 again. Then we're going to connect these all. Okay. And I'm going to do city 2 and city 3, and I'm actually going to pause the video to speed up time. And so I'm going to pause the video and graph these, so go ahead and you do that too. Alright, and here is the city 2 and city 3 information plotted. And what we can do here is this. Let's say that I were just to give you this data with this line graph in these 3 cities, and I would ask you to make some comparisons. I'd go, which city, if these were all taken in the same week, so this was all recorded on the same Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, during, let's say, April. If I were to tell you that, and I went, which city do you think would probably get more snow in the winter? Looking at the temperatures, you can kind of compare. Well, one of these is a lot colder for April, so I bet it's even colder in December, January, so you might say city 3 because it looks like it's colder there. If I were to say which one do you think is closer to the equator, you could make some comparisons there. So line graphs give us this opportunity to compare multiple points of data over time. And these are the 3 ways to represent data. So we're done with this video, so go ahead and move on to the next thing.